Hello and welcome back. This video is going to be all about bearings. Most of the bearings that we're going to deal with in this class are going to be related to the wheels. Hubbed drums and hubbed rotors, or captive drums and captive rotors, those will involve disassembly and removal of the different types of wheel bearings that we're going to be discussing. This class may also get into rear drive axle bearings that are located out near the wheel as well, but that involves servicing the differential and removal and installation of some other components that we won't be covering in this class, but we'll discuss the bearings. So what is the purpose of a bearing? The bearing's job is to take two components and reduce the friction in between them. So we have there would be a component that is attached to the inside or the inner race of a bearing, and a component that's connected to the outer race of a bearing. And with the precision rollers inside, that has to maintain a very smooth surface. With those two pieces together, we can load a heavy component against another component and have pretty smooth operation moving through these bearings. The common types of bearings that you're going to see in automotive are roller bearings, double row roller bearings, tapered roller bearings, double row tapered roller bearings. A ball bearing, like this one, has hardened steel balls spaced evenly around the inner and outer races, and that allows for rotation. Now the ball bearing is only at one point of contact for each ball on the inside and on the outside. So we only have a tiny little point where that ball is touching the outside and the inside. So it has very, very little rolling friction. But what it doesn't have is the capability of supporting heavy loads. So they operate at light loads at higher RPMs because of the reduced friction, the reduced rolling friction. This bearing can only support radial loads, so loads that are perpendicular to the races. The reason for that is because of our single point contact. If we put any sort of axial or thrust load on it, it's going to cause that bearing to walk out of its path, and that would likely damage the bearing, and it wouldn't support the load. Bearings that do support loads from the side or from thrust are tapered roller bearings. The taper gives them the ability to not only support radial loads, but also thrust loads. So this bearing, if I push both of these halves together, like this, it's designed to operate normally like that. Bearings generate heat, and they need to be greased or oiled. And the grease and oil aids in lubrication and removal of heat from the friction components, from the heat of them rolling against the surfaces, and that heat builds the more load that's on it. One unique thing about tapered roller bearings is that they can be serviced. A very common configuration to come across in automotive applications is tapered roller bearings that are facing each other that are not sealed. These are serviceable, and they are held in place with a castle nut and a washer, and these will be mounted into a hub assembly. Now when these are mounted into a hub assembly, there is a missing component here. Just like on this example, what we're looking at is a tapered roller bearing. What it needs in order to operate is an outer race, or a bearing cup. These bearing cups will likely be pressed into the hub. And once the bearings are installed into the hubs, they need to be adjusted for the proper amount of clearance. Now, why do they need clearance? Well, when things heat up, they expand. As that expansion happens, there needs to be enough room for them to expand and contract with temperature, heating and cooling, in order to maintain safe and smooth operation. But if they're too loose, they won't ride on the race surface correctly. They may walk towards the inside or the outside. And if that happens, that roller is going to make more contact in one spot than another, and it's going to lead to premature bearing failure. Or in the worst case, they'll overheat to the point where they expand and seize. So adjusting the bearings for proper clearance is going to be one of the main services that we do on this type of tapered roller bearing. The other common type of bearing is a sealed bearing assembly. This one has been taken apart, and this is the previous example tapered roller bearing, but a double row tapered roller bearing. So one row here and one row here. And the outer race is one solid piece machined to fit two separate inner races. Here's one of them. And with one side installed, this is what they look like on the outside. From the inside, you can see the inside of the rollers and the inner race. So out of the box, when you replace these, it won't look like a roller bearing, a tapered roller bearing. You won't be able to see the rollers themselves. What you'll see is this cylindrical piece with seals on both inner and outer sides, and then on the inside you'll see where the two halves of the inner races come together. This unit needs to be pressed in and retained with a clip or a retainer ring, and then when they are replaced they need to be pressed out, and it's a press fit. So there's no preloading, there's no clearancing or anything, but it is a different process in order to service these bearings. Depending on the application of the vehicle, the sealed roller bearings may be like this one, which are a tapered roller bearing design. So again, we have tapered roller bearings opposing each other, so this can handle thrust loads in both directions, and they are tapered roller bearings so they can support a heavy load. I would imagine this came off of maybe the front of an SUV. You can also use ball bearings in order to support thrust loads and configure them in a very similar way. So these ball bearings would have, this is not the matching set, it's close though, almost goes together. But you have two halves of inner races like these. And you can see that the profile of where the ball bearing rides in this radius right here, and it's angled to support a diagonal load, so like this almost. And on the inside of the outer race, we have the same opposing angle coming from this ball bearing surface right here. Now with this piece machined to accept two rows, so two rows of bearings, of ball bearings, in one sealed housing, with everything put together and everything tightened and torqued to specification, this bearing will support thrust loads because of the dual opposing angles that the ball bearings are riding on. The advantage that this has is that it can operate at higher speeds and maintain a cooler temperature, as opposed to the tapered roller bearing that's going to generate a little bit more friction from those wider rollers, and instead of a point contact, they'll have a line contact for each roller. Between these two designs, they can both handle thrust loads from both directions, or axial loads, and they can support radial loads. The difference being that the ball bearing one can operate at higher speeds and support less load, while the tapered roller bearing can operate at lower speeds and support higher loads. So depending on the application, the manufacturer will engineer it one way or the other. I briefly covered the process of how to service serviceable wheel bearings in an earlier video. I believe it was brake drums. I believe it was this brake drum. So this brake drum does not come off unless we disassemble the bearing that's contained within here. And this is a serviceable bearing setup. So I'm going to go through the process of disassembly, packing, servicing the wheel bearings, and reassembly, and then adjusting for the clearance. First step is to remove the cotter pin. Cotter pins are pretty soft, and it works pretty well to use some side cutters for grabbing and pulling. The sharp edges on them make them great for removal. Cotter pins, always, always, always throw them away and replace with a new one. Remove the retainer. This is what helps keep that nut from backing off and the wheel from falling off. Take our nut off. These nuts should not be very tight. You'll find out why in a moment. Then we can remove the drum, and then remove from the drum our outer wheel bearing. And here's the washer that keeps it from trying to spin the nut free. And that washer has a little tang on it. A little tang right there. And it rides on a groove right here. So this washer is designed to separate the back of that bearing from the back of the nut, so the bearing's rotation doesn't transfer into the nut and try to back or tighten the nut while the vehicle's moving. So these washers are key, and no pun intended, the key on the washer is important. So with the outer bearing removed, inside here is the cup, the bearing cup, or the outer race. That's pressed into the hub. That doesn't need to be removed unless it's being replaced. Flip it over to the back side and use a seal puller or a similar device. I find that a small pry bar works pretty well for these. And you slip it behind the wheel bearing. Pop that out of place. This keeps the grease inside the hub assembly to lubricate and cool the bearings without getting onto your brakes. Then our larger inner bearing, here's a size comparison from the outer to the inner. You can probably guess which one supports more of the vehicle's load. Bigger is definitely, in engineering, going to support more. So now we have our inside of our hub assembly, and we want to wipe all the old grease out and inspect for any damage. Nice and clean. You can see the bearing surface in there. Going to do the same to the front or to the outer. Gloves are very good to wear when you're working with bearing grease, because you'll get dirty in a hurry, and then it's really easy to keep your hands clean by popping those gloves off. So there we are, all clean. We give it our inspection. looking for signs of brittling, spalling, pitting. If we don't see any indications of damage, then they don't need to be replaced, and we can continue servicing the wheel bearings. The next step is to clean the excess grease off of the roller bearings. We inspected the races for wear. We inspected the races for damage, signs of overheating, discoloration, pitting, spalling, brittling, which is more like flaking. And we did not see any of that. And you're not going to get them 100% clean. When we grease them, that will actually move some of the old, worn out grease out of them. So here's the inner bearing and the outer bearing. Use the same greasy rag or towel. Get those nice and clean. If you do use solvent in these, you run the risk of contaminating any new grease that goes into the bearing, because there's no guarantee that you're going to get all of the solvent removed from the bearing before introducing new grease. And solvents are solvents because they dissolve certain materials. And most automotive solvents will dissolve the grease or break it down. So any solvents, including brake clean, brake parts cleaner, or parts washer solvent, if that gets into the bearing, there's a good chance that that bearing will fail due to the grease breaking down. So there's our outer bearing, nice and clean. This is a bearing packer. This is my personal one. It's nice and clean, and I keep it nice and clean. I just changed my gloves because the other ones were all greasy. Note how clean it is, and I keep it clean. So it is possible, even though every time you come across one of these, it will be caked in grease on the outside. This is our grease protective cover, keeps the dust and dirt out of there. So what this has is a plunger on top, and it has a tapered seat on it, and it unscrews from the bottom peg, okay? In the middle, we have a Zerk fitting or a grease fitting that we can pump grease and fill the lower chamber with new grease. And this is high temp bearing grease. It's the good red stuff. This white portion here and an O-ring are what seals the upper chamber from the bottom chamber. In the center, down at the base of that peg, are looks like 8 holes that grease can come out through. We're going to put the bearing in between this lower piece and this upper piece, and then press down on the whole thing. And as we press down, grease from the bottom part is going to be sealed by this O-ring and forced up into the bearing from those holes at the base of the peg. So I'll show you how that works. When you put the bearing in, put it tapered down. So there's our bearing. And the upper piece. So now we're going to put some weight on it. Gonna rock it around a little bit. And you can see that old nasty grease is being pushed out by the fresh stuff coming in from the bottom. It's good to have a nasty rag handy so you can take that old grease. This is another trick to keep your hands relatively clean. And wipe some of that grease out of there, because we want all new grease to go into the new bearings, or into the bearings that we're putting back in. Gonna do the same thing again. And you can see that grease just forced right past all those rollers. So I'm gonna wipe off the old stuff. And then coat the outside of the bearing with some extra new stuff. And then we'll set this aside and it'll be ready to be installed into the hub assembly. Move on to the next bearing. Now, something that might happen over a long period of time, if you do a lot of bearings like this repetitive motion of forcing this plunger down can actually deteriorate the cartilage in your wrists, or the soft tissue in your wrists, or maybe somewhere else, maybe your shoulder, maybe your elbow. There are methods that I like to use that reduce the strain on your body when doing this. So I'll show you for the inner wheel bearing. So we got the larger inner bearing going in, taper side facing down. Same setup. Always have towels and rags handy when you're working with this. And what I'm gonna do is take a large pry bar and hook that onto the vise and move this towards the end of it. Now what I've created here is a lever, almost like a brake pedal. We have a few inch offset from our fulcrum, and we're going to multiply our mechanical force that we're going to apply to the lever out here, and it's going to amplify the force down here. So if we just guide it by holding it in place and we press down on the handle here, as long as it's nice and secured on the other end in the vise, we can press down, and with very little effort that pushed a lot of grease through there real quick. Way less effort than I was using before. Again, we don't want any of this old grease, so we're going to discard it. I'm going to keep my tool nice and clean. This is one of those tools that most shops will have, but also one of those tools that I don't want to share, so I'm going to have my own. Get rid of all that nasty grease. We only want the good stuff. Grab some of that excess red grease that's in there, coat the outside of our rollers, and those are packed and ready to be installed. Just packing the bearings and leaving the hub clean is not enough for there to be sufficient cooling of the bearings with the grease. We need enough grease in there, and typically more is better, but you can have too much grease in there. So there's a threshold, and it's a pretty forgiving threshold. So we're going to put some grease into the bearing, into the hub for the bearings, and then reinstall the bearings and finish the service. I'm just going to lay it in there and wipe it into the hub. There's some vacant space in there that's perfect, and if you just use your finger as a gauge in between the two races, the inner and outer race, and just work that around inside. We want a liberal amount of grease in there. Flip it over to the outside and make sure that we have enough grease there. And I think that will about do it. Nice and clean. So the first thing to go in here is our inner bearing. And then the seal that keeps the grease in there is normally replaced when doing the service. Replaced with a new seal. This is our new wheel seal going back into the hub. We also want to inspect the spindle for any damage or signs of wear. And everything on this one looks pretty good. Here's that groove that the washer rides in. And then at the very back, right here, this is the surface around my fingertip. This is the surface that the wheel seal rides against and seals the grease along this whole spindle. So for reference, here's that other spindle, very similar. And the way it stacks up on the other spindle washer with the tang. This is called a castle nut. It's very similar to the retainer that we have for the application we're working on currently, but the nut is actually cut and formed so the cotter pin can pass through the nut itself, rather than having to use a more flimsy retainer. And then that is threaded onto the spindle to complete installation. So that's what we're looking at inside of our hub assembly. So let's finish this job. So now we're ready to complete our installation of the bearing and hub assembly with the drum. Got to line a few things up, guide it on there. Now we can install our outer bearing. Keeping things manageably clean. Not looking for spotless, but just not excessive. Next piece, washer with the tang. Then our spindle nut. Okay, that spindle nut is just on there hand tight. I can back it off, tighten it. As we rotate the wheel a little bit, we may get a little bit more adjustment out of it. This method, for what I'm about to do, sets the clearance on these tapered bearings. This works for larger trucks, it works for passenger cars, it works on boat trailers, it works on flatbed trailers, it works on all kinds of different applications where you have serviceable wheel bearings. This is the process. 1/2-inch ratchet, 1/2-inch drive socket that fits this nut. Put it on there and tighten. Spin and tighten. And if you can, spin it while you tighten it until it is fully seated in there. We are seating these bearings in against their bearing cups, and that is tight. If we were to drive the vehicle with the bearings this tight, they may not last a day. They'd burn up, seize up, and just fail altogether. So now, at this point, the next step, set it to loosen. The key here, and I think it's best to use a deep socket so you can grab onto it while still being able to use the wrench, or still being able to use the ratchet. By doing this, you can hold on to that socket while you loosen. And what I'm doing is I'm putting overrunning pressure on the socket. So the instant that it gets loose enough to turn by hand, I will turn it by hand. Until then, I'm using the handle, and I'm just going really slow, and it's not hard on the handle right now. It's getting pretty easy. And once I get to this point, right there, set that back to tighten, hold this at 3 o'clock until it gets hand tight again. So after we seated the bearings in, we back that off without loosening the bearings. So the bearings are still sitting right in their seats where they need to be. We loosen this up with the aid of the ratchet until we could spin it by hand, and then we immediately rotate it back to where it's hand tight. So it is just snug right now. This would be too loose. If we were to put the retainer on and ship it at this point, this would not be enough this would be excessive clearance for the bearings. Here's the last part of it. While supporting the wrench, while supporting the ratchet, spin the hub and push this down very little. That's all you need. Find where this lines up. One new cotter pin. Cotter pins have they're one solid piece. They come up to a loop. One side is shorter than the other side. So that goes through. Put it just like that. Now some people bend these different ways to lock them in place. The important thing is that the cotter pin keeps the retainer from rotating so the nut doesn't rotate out while the wheel is spinning. But I'll show you how I like to do my cotter pins. I like to make sure that loop is in there nice and tight. I like to make sure this loop is in here nice and tight, and I'll even keep a little bit of pressure on it while I take my side cutters and just lightly grab that longer tang, and I'm pulling out and around till I come back over the top of it. Give it a few taps, and then this end, if I clip it, it's going to go flying. If I put the side cutters on it and I grab the end of it, there it is. Normally there's a bearing cap that would get tapped onto here to keep this area free of dirt and contaminants getting in there into the hub and contaminating the grease. This is a classroom bench model. You will have the chance to service the bearings on this, and this one doesn't have a bearing cap on it. So again, this is a very common procedure to do on older vehicles. A lot of rear-wheel drive vehicles with serviceable front hubs will have this design. You'll come across it. It'll be present in the industry. It'll be something that you come across and find. Also, like I mentioned, trailers are a good source for this type of bearing. Trailers don't drive, so there are no drive axles, and typically they're going to have spindle hub bearings, and they need to be serviced in this kind of way. This method, again, works on a wide range, and there have been variations of information on how to do this. This is more the agreed upon method in industry amongst fellow instructors and fellow technicians in industry, how to do the bearings. and to not have them come back on a failure due to this method of installation. So, ready to roll. Next, we're going to check out a few items of failure. When you see this type of color in a bearing, most of the time it's due to water getting in there and starting to rust, and that rust mixes with the bearing grease, and that bearing grease turns real thick and contaminated, and that's evident on the roller surfaces. Now this one actually has, I think, some pitting in it. Yeah, I can feel it. This is evidence of spalling. And the number one failure of bearings is heat. And you can overheat bearings by over lubricating them. You can overheat them by over tightening them. You can overheat them by overloading them beyond a vehicle's weight rating. If the seals get bad, if the seals go bad and water can get in there, that can ruin them too. If installation was not done correctly and you have uneven seating of bearings on their surfaces, then that can lead to problems as well. Brinelling is when an impact will affect the bearing. There, maybe you can see a little bit down there. You can see these little dots. These are the profile left behind from the roller bearings, and over on this side it's not so present. There's more. What happened, what I suspect happened, was just a hard hit, like a pothole. Ever seen one of those around Portland? Yeah, me neither. Anyway, I didn't see this one, or I saw it too late. And this was on the rear wheel. And this is the inside of the hub that it's from. And maybe you can kind of see a little bit of the imprint left behind from the ball bearings. So the ball bearings were right there during the point of impact. Now, how did I know that that was the issue? Well, I didn't know right away. And it took a while to figure out, especially since it was on the rear. But when finding noises like bearing noises, they're often going to be under load is when they make noise. The primary objective of the test drive is to duplicate the customer's primary concern. When you're test driving a vehicle, there are other things you're going to do on the test drive to help narrow down on anything else that might be occurring in the vehicle at the same time. Whether that's warning lights or functions of certain things or noises that you hear, those are all things to write down and jot down in your tech notes. Then when you present your inspection notes to the service advisor, you can also address, hey, there was this vibration at 40 miles an hour and it got worse upwards to 55, for example. A good way to test wheel bearings when driving is to go in like an S-shape swerve, a slow and steady swerve to where when you turn left, the vehicle loads to the right side and you hold it loaded for a duration of that curve before letting off and then turning to the right and loading the left side. If you have noise that goes away depending on loading one side versus loading the other side, if the noise comes and goes when you transfer the load of the vehicle from side to side, that's usually a sign that a wheel bearing is going bad. By doing this maneuver and be as legal as possible about it, Try to do it somewhere where you're not going to freak out other motorists or do it in front of any police officers. Stay within the constraints of the law. Do it in a parking lot. Do it under private drive. Do it somewhere where you're supposed to be able to find it. When you turn left, the weight transfers to the outside on the right. And if the noise is present during a left turn, then the faulty wheel bearing is likely on the right side, if that's when the noise is made. And then if you turn the other way to the right and you load the left side, then that bearing that may be making noise is either making noise on the left side, or if it was on the right side, it would have got quiet since it is now unloaded and not supporting that load on the bearing surface. Also in test driving, if you drive over different types of road surfaces, if the noise changes with the road surface, then it's usually something to do with the tires. Either it's just the tires themselves that do that and change pitch on the different road surfaces, or you have an issue with the tires that needs to be resolved. But typically your tires are going to change pitch depending on speed and what type of road surface you're driving on. If the noise remains the same, if that growling, humming, growling noise stays the same regardless of the road surface, then you can probably test towards the wheel bearing failure. Wheel bearings, when you check them, you're going to put force on the tire up and down alternating, and there's supposed to be a little bit of play there. That's our clearance in the bearing. There should only be a little bit though. If you feel it, it's normal. If you see it, it's excessive. Over time, you'll develop a feel for what's correct and what's not correct. But a bearing that is too loose will have excessive play. If you spin a wheel and you hear growling noise or grinding noises, this is with the vehicle in the shop lifted off the ground. And if you spin a wheel and you hear growling noises, that's also an indicator. One of my favorite tools for wheel bearing noises, if you're in the shop, the old stethoscope. There is a metal diaphragm at the end of a long rod, and this amplifies noises. I heard every little bit of that threading in there. This amplifies noises coming through the rod. So you can touch this into any solid component. So a bearing, let's go to the spindle itself since it doesn't move. And I can hear that that is very silent. Sounds smooth, very smooth operation. No hiccups, no growls, no pops, nothing going on in there. If I suspected a certain bearing or I suspected a bearing on a certain side, I could go to that wheel, and usually from the back side. So the tire's still on, wheel's still on, everything's still on. It's just lifted off the ground and I'm underneath it. Find my way up to a component that's near the spindle or the bearing. As long as it's not a moving component, you can put this on there. This does amplify noise, and it's loud. If you get the wrong piece on it, I've hit fans, radiator fans, belts, things like that when you're trying to narrow down on another issue. So be careful with those. Be careful with your ears. Wear ear protection. Hard to wear ear protection when you're trying to amplify noise into your ears. So be careful using a stethoscope. Well, there's definitely more to discuss on wheel bearings. We skimmed the surface of it, and I hope I showed you a good portion of what's involved, especially with servicing serviceable wheel bearings. We didn't get into press fit wheel bearings. I don't have the tooling to do that here. But live in the shop, that's the time to learn a little bit more. Plus, the slideshow and the text go into a lot more detail about the specifics related to types of lip seals and grease differences, synthetic versus non-synthetic, that sort of thing. So a lot of that trivial stuff is covered in the text. I hope this was not too boring to watch. Some of these may be more than others. So I hope to bring a little bit of liveliness to this online remote course. And again, thank you for joining me on Wheel Bearings. Catch you on the next one.